Good morning, everyone. I am Mr. Ish. Thank you for joining me. We're doing here a comprehensive review on the radius of convergence and interval of convergence. Two difficult concepts. Students normally study it and then they forget it quite quickly. We have to revise this material. It's essential that we revise it. If you are looking here at a power series and by means of the ratio test you evaluate it, you can end up with something which looks like this. There's a certain expression here. There's a limit as n approaches infinity, and then your n function over here. You know, when you evaluate all of this, you have three specific outcomes which come. You can have one outcome which arrives such that the limit over here will tend towards 0, and then you're looking at this x and a item, whatever it might be right here, which is in the absolute value. It's being multiplied by the 0 and it zeroes everything out, which is not bad because it's telling you you have a radius of convergence which is infinity and interval of convergence which is minus infinity to infinity, because everything was tending towards 0. This part right here, the limit tending to 0, zeroes this part out. It drives this process. You can verbalize this as saying that the series converges for all values of x. There's another situation which arises where limit, as you're doing this n approaching infinity, this part right here is tending towards infinity. So essentially you're looking at something which is xa over here and it's being hit by infinity, and then everything is becoming divergent, and you see that. In this particular case, you know the radius of convergence is very severely limited to perhaps a single value. Your interval of convergence can be limited to that single value, or it could be another value. It doesn't have to be 0, but it's limited to a single value because here your series is convergent only for that single value. Beyond that single value, everything is divergent. You would put that single value right here in place of x. It would zero this out, which would then zero everything out. You can see it as this in terms of an example. You can also see it like this, as like that in terms of an example. Then there's a third case when you're evaluating this limit. It's not tending towards 0, it's not tending towards infinity, but it's ambiguous. It's like inconsistent result. It's equaling a 1. So then you're looking, or you're forced to look only at this part right here, x minus a. Then you're looking at that. You're looking at x minus a. You're looking at all of that. And you know there are specific values for which the series is convergent, but then all the other values it's divergent. Here you'll see that your radius of convergence is limited to a single item over here. That item can vary based on what it is. And your interval of convergence can also again vary. You could have x, you can have some sort of value here, some sort of value here, and then you're looking at it in terms of inequality signs. You don't know what those inequality signs are. They have to be figured out. You could have situations where you have this, the endpoints are not included. A single endpoint is included, as you can see right over here. Single endpoints included, the other endpoints are not, or you can have both endpoints included, and of course x will adopt the values in between. These are the four situations which can arise from right here, but in this particular case the radius of convergence varies, your interval of convergence varies. Here there's a specific value, your r value, your radius of convergence value for which the series is convergent. And this radius here will obviously vary based on what this expression turned out to be. In this video I want to examine three quick examples which will look at each of these three cases, hence it will be a good comprehensive review for all of us. That represents our first example. From n equals 0 up to infinity, we have minus x to the power of n times n plus 1 divided by 2n factorial. You want to look at everything here by means of the ratio test. What's your a-nth term? It's exactly what you see right over here. What's your an plus 1 term? Of course you know how to do that. Minus x to the power of n plus 1 times n plus 1, which is n plus 2, divided by 2n plus 1 factorial. The ratio test requires you to look at the absolute value ratio of this, with this in the numerator, that in the denominator, and bring in your algebraic manipulation. You can separate this into its individual base and exponents. You have this, and then obviously you have n plus 2. You can also manipulate this. You're looking at 2n plus 1 times n factorial multiplied by this. Remember, this would be a denominator, but it would undergo a reciprocal effect, and you would have exactly that come out. Minus x to the n, and then n plus 1. Close the absolute value. What cancels out? The 2 cancels out, the n factorial cancels out, the minus x to the n cancels out. In essence, what remains is this, that, and that right there. Limit as n approaches infinity, you have this n plus 2 here in the numerator. You have n plus 1 times n plus 1, which is n plus 1 whole square. You have a minus x to the 1, which is a minus x, but in the absolute value you can bring it out as that. You know when you're doing the limit evaluation for this part right here, it's gonna tend towards a 0, a horizontal asymptote y equals 0. You can do this limit evaluation, it tends towards 0. Essentially, you're looking at minus x times 0, you're getting a 0. This tells you for any value of x, your series is always convergent. A very ideal case. Radius of convergence here is infinity. Your interval of convergence is minus infinity to infinity. This was like that very first case I was showing you at the very beginning in terms of the 3 examples which can arise. Any value of x, your series is always convergent, and these are your answers and they should be good. Let's modify this for another example. I'm going to change this n equals 0 up to a 1. I'm going to get rid of this because obviously 0 factorial works, but 0 in place of n here in the denominator will be undefined. But this right here represents our next function, series function, n equals 1 up to infinity minus x to the power of n times n plus 1 divided by 2n. We have to evaluate this. Obviously this right here is your an term, minus x to the power of n times n plus 1 divided by 2n. Your an plus 1 is minus x to the power of n plus 1. You have n plus 2. Here you have 2 times n plus 1. You know the ratio test is this divided by that in terms of absolute value. You'll have minus x to the power of n times minus x to the power of 1. I'm separating these out right here. Times n plus 2 divided by this 2 parentheses n plus 1 times this undergoing a reciprocal 2n divided by minus x to the n times n plus 1. Close the absolute value. Now what can you cancel out? You know there's a limit obviously here. Limit as n approaches infinity. 2 cancels out. Minus x to the n cancels out with that. What remains? I have an n plus 2, n minus x, n plus 1, n plus 1. This minus x will come out as this. Then I have limit as n approaches infinity. I have this n plus 2 multiplying by n. I have an n squared plus 2n. Here I have an n plus 1 times n plus 1, which is n squared plus 2n plus 1. You know if you evaluate this, y equals 1 is a horizontal asymptote, but it also represents your limit evaluation. It's 1. It's an inconsistent result. You're really looking at absolute value of x times 1, absolute value of x. This right here is your end result. It's an inconsistent case. It's like that case 3 which I was talking about at the very beginning. It will be obviously less than a certain value for which it will be convergent. What will that value be? Absolute value less than 1. You know now your radius of convergence is equal to a 1, so that part is done. Absolute value of x is less than 1, x is less than 1, x is greater than minus 1. You have a interval developing over here. X is in between, you have a 1, minus 1, but you don't know what type of inequalities develop over here for your interval of convergence, but we have to determine that, and we will, and it's not hard. You take these endpoint values minus 1 and 1 and you put them in 2 places of x here in your series. When you look at minus 1, you put minus 1 here, you get a minus 1 to the power of n. You're looking here 1 to the power of n, which is meaningless. You're really looking at n plus 1 divided by 2n, and then you know your series is being evaluated from 1 up to infinity. Just use the integral test. It's easy right here. You're really looking from 1 up to infinity, n plus 1 divided by 2n dn. You can separate these. You'll have n over 2n plus 1 over 2n. You're looking at that. dn, but when you do this, you know the natural log will come out from right here and you'll end up seeing divergence. That tells you clearly when minus 1 is placed in here, you're getting this. It's not a value that creates or brings about convergence, it's a value outside and it's in the divergent aspect of the series. So minus 1 is outside of this radius of convergence and you can see it represented by means of that inequality sign. Now when you put 1 here into the item, what do you get? You get minus 1 to the power of n and then n plus 1 over 2n. When you're looking at this and you want to evaluate this in terms of the convergence or divergence, you can use alternating series test, or you can use some sort of limit procedure divergence test of limits, and you can end up manipulating and bringing in the constant multiple property. You'll bring out the minus 1 over 2. You'll have limit as n approaches infinity. You'll end up seeing 1 to the n times n plus 1 over n. Minus 1 over 2 has been pushed out. This becomes meaningless. When you look at this, n plus 1 divided by n, you know this will evaluate here to a 1. But all of this will end up evaluating to minus 1 or 2. This does not tend towards 0. It tends towards minus 1 or 2, which is a divergence value, and you end up seeing that that's the interval of convergence. You have inequality sign which does not have the equal in it, so your interval of convergence is minus 1 comma 1, but with these circular parentheses, and this question is done. Radius of convergence 1, interval of convergence to be that, and both of these answers should be good. For the last question, we've modified everything to this now, from 1 up to infinity, x minus 1 to the power of n times 2n factorial, and that right there represents your anth term. Your an plus 1 term will obviously be x minus 1 to the power of n plus 1, and then 2n plus 1 factorial. You have to do the ratio of these two, and we will. You have x minus 1, and we'll spread them out using laws of exponents. This is to the power of n, and it's to the power of 1. And then obviously here you're going to have 2 times n plus 1, and then n factorial. That's manipulating all of this expression right here. Now let's look at this. X minus 1 to the power of n, and then 2n factorial. And this right here represents a ratio. Things cancel out. This cancels out with this. The 2 cancels out, this n factorial cancels out. The only thing which remains is this right here. You have an x minus 1 to the power of 1, which I'm not even writing. Limit as n approaches infinity. I have this n plus 1. This n plus 1 right here is obviously going to tend towards infinity. I'm looking at x minus 1 times infinity, and I'm getting infinity. But we're seeing that there's no value for which this series would be convergent except if you were to solve this. X minus 1 is equal to 0, x is equal to 1. If x were equal to 1 and would be placed right here, we can then convert everything into a convergent. All the values of x for this series will be leading to divergence except for a single value, and that single value is x equals 1. How would you state your answer here? Your radius of convergence here is basically a 0. Your interval of convergence here is, you can put it like this, 1, and that'll be it. Radius of convergence 0, because there is no radius of convergence. That specific value is it in terms of what will create convergence, and that value is represented right here in terms of your interval. That's it for this comprehensive review. Thank you for watching.